All right, so 2.4 is going to extend what we did in 2.3. We're going to get to a little bit more complicated equations than we saw in 2.3, and we're going to start talking about the distributive property when we are solving equations. So that's the main goal of this learning target, is to talk about the distributive property and what that looks like when it comes to solving. And then additionally, we're also going to talk about what happens when equations have no solutions, or sometimes equations will have infinite solutions. Those are kind of the two big goals for this learning target. The first thing that we have to remember is what the distributive property is. And you've talked about this in middle school. We're just going to kind of refresh here. So this is my definition of the distributive property. If I have a sum or a subtraction instead of parentheses and a number on the outside, I'm saying that that number on the outside can be multiplied to both numbers on the inside. I'll put multiply here. Can be multiplied to both numbers on the inside. So it would look like whatever A times B is plus whatever A times C is. So that's your basic definition of the distributive property. How does that look like when we actually put in numbers with that? So let's look at this first example. If I distribute the 5 to both of these inside, I'm going to do 5 times 2m, which is going to give me 10m. And then I'm going to do 5 times negative 3, which is going to give me negative 15. Okay, so I'm just distributing that out. And we don't have any equal signs right now. There's no solving yet. I'm just showing you the basics of distributive property. Okay. The second one, same thing. Now we're going to distribute the 8 to both things inside. 8 times 4 is 32. And then 8 times negative b, there's like a little invisible 1 right here. So it's like saying 8 times negative 1. That would be negative 8b. And so there's our distribution for that example. And then the last one is just a simple sum. We're going to do 7 times x to get 7x and 7 times 4 to get positive 28. Okay, so that's how basic distribution works. So let's take a look at what that looks like in an equation to solve. Okay, so let's take a look at example 1 here. So just like all of our other equations that we're going to solve, we're going to draw our line through the equal sign going down. But now we're going to have to get rid of the parentheses first before we start adding or subtracting anything to both sides. So I'm going to distribute that negative 3 to both things inside the parentheses. So I'm going to get negative 3, and then negative 3 times positive 4x is going to give me negative 12x. Bring down that plus 5, and bring down the negative 94. Okay. Now this looks like an equation like we did in 2.3. Now I can look at my left side and combine like terms. The number 5 and the number negative 3 can be combined. So I'm going to bring down that negative 12x, and I'm going to combine the 5 and negative 3 to give me a positive 2. Then I'm going to subtract that negative 2 on both sides. And I get negative 12x equals negative 96. And then I'm going to divide both sides by negative 12. And I'm going to get that x equals a positive 8. Okay. Example 2 also has distributive property, but there's something a little bit different about it. Draw your line like normal. Notice that in front of this set of parentheses, I have this minus sign, but there's no number. It just means that there's an invisible 1 here. So I like to draw in that invisible 1, and then you have to distribute that invisible 1 to both things inside. So negative 1 times negative 6 gives me a positive 6. Negative 1 times negative 4r gives me a positive 4r. And then bring down the 16 plus 2r. Now we're going to go ahead and start moving things to the left and the right. I like my variables on the left, so I'm going to start by subtracting that 2r to the other side. They cancel out, and I get 6 plus 2r equals 16. Then I'm going to subtract the 6 over. The 6's cancel out, and I get 2r equals 10. And the last step is to divide that 2 away, and r is going to equal 5. Okay. I've got 2 more examples here with the distributive property. And these examples have to do with having 2 sets of parentheses in a problem instead of just 1. So we still draw our line like normal. Now to start off this problem, we've got to get rid of both sets of parentheses. So I've got to distribute the 2. Oh, my lights just turned off in my room. Hold on. Sorry about that. That was weird. Okay, so we're going to take the 2 and we distribute it to the 1 and the 2 distributed to the A. And then we're also going to distribute this -2 right here to the 3 and the 3A. So we have to distribute twice, 2 times. So I'm going to get 2 times 1 is 2, minus 2 times A is 2A, -2 times 3 is -6, and -2 times 3 is A is -6A. So I've gotten rid of all my parentheses, and now I can go ahead and combine like terms and start solving. So my like terms here are this 2 and -6, and then I've also got a -6a and a -2a that are like terms. The -2a and -6a combine into -8a, and the -6 and +2 combine for a -4. Okay. Now I'm going to add the 4 over. The 4's cancel out, and I'm left with -8a equals 8. Divide both sides by -8, and I get that a equals -1. Okay. And then the last example is similar. We've got 2 parentheses like in example 3, but now it's 1 on each side. So the same thing, we still draw our line, and we're still going to have to distribute both these sets of parentheses first. So -4 times p is -4p. -4 times -5 is +20. Bring down that 5p, but you're going to distribute the 2 to the p and the 2 to the 6. So you're going to get 2p and you're going to get 12. Okay. Now on the left, it stays the same. There's nothing to combine on the left, but on the right, I can combine the -5p and the 2p into -3p. Okay. Now I'm going to go ahead and start moving things to the left and the right. I'm going to add the 3p over, because I always like to get my variable on the left first. They cancel out, and -4 and -3 combine to give me a -1p. Bring down the 12. Then we're going to subtract the 20 on both sides. And I get -1p equals 12 minus 20 is -8. And then I've got to get rid of this negative in front of the p. So I'm going to divide both sides by -1. The negatives cancel out, and I'm left with p equals +8. Okay, so those 4 examples are your basics when it comes to using distributive property when you're solving equations. So that's the first part of 2.4, is being able to distribute correctly, combine your like terms, and solve and get a solution. The second part of this learning target is talking about different types of solutions. Okay, so we've got 3 different types of solutions. The first type of solution is what we've been working with this whole time, and that's a one solution. Okay, where x is the variable equals a value. So we can say the variable equals a value. Okay, and this is what we've been doing the whole time. We've only seen equations that have one solution. So for example, 2x plus 1 equals 7. If we solve this equation, subtract the 1 on both sides, 2x equals 6. And then divide both sides by 2, x equals 3. That is just one answer of 3, okay? One solution to this equation, okay? The second type of solution is a no solution equation, okay, where we solve it and no value will work. So there is no value that makes the equation true. Okay, just no answer will actually fit in this equation. And what this looks like when you solve looks kind of interesting. So I'm going to draw my line and solve this like normal, because you won't know if an equation has one, none, or infinite solutions before you solve. You'll only know when you get towards the end, and some of these numbers will get kind of weird. So we're going to solve this like normal. Distribute the 5 to the inside. So 5x minus 20 equals 5x minus 27. And then you're going to do what you normally do. You're going to try and get those variables on the left side. So we're going to subtract the 5x over. And when you do this, something really interesting happens. You have to be really careful here. 5 minus 5 cancels out to 0 like we want. But notice on the other side, we also have 5 minus 5, which cancels out to what? It cancels out to 0. So these go away as well. And suddenly we're left with an equation that has no more variables at all. So we're going to bring down that negative 20 on the left. We're going to bring down the negative 27. And you're going to look at this and you think, wait a second, this equation is saying that the number negative 20 is equivalent to the number negative 27. Is this true? No, this is not true. That's just a false statement. Mathematically, that doesn't make any sense. So the answer to this is there's no solution. This is saying this is a false equation. Okay, so if you get to a point at the very end where all your variables cancel out and you're left with two numbers that don't equal each other, that's a no solution. Okay. On the other hand, we can also get to a problem that has infinite solutions. And that looks even a little bit more, that looks different as well. Let me angle my camera up a little bit here. Okay, so if we solve this one like normal, okay, well, let me first, so if we have something that has infinite solutions, let me take a step back here. Unlike a no solution where there was no value, an infinite solution, any value makes the equation true. So we could pick any number we wanted, plug it in for x into this equation, and any number would work. How do we know if that's the answer to our equation? Well, let's see. If I start solving this, I notice first there's an invisible negative 1 here in this problem that I'm going to have to distribute. So that's kind of tricky right off the bat. So that negative 1 has to be distributed. Bring down your 6x. Negative 1 times positive 1 is negative 1. And negative 1 times 5x is negative 5x, and that's going to equal x minus 1. Then we're going to combine like terms. So I've got a negative 5x here and a 6x here. That combines to 1x. So I'm going to have 1x minus 1 equals x minus 1. And here you might notice something weird already. You might notice that the left and the right are identical. Okay, and if you don't notice that, that's okay. We're going to keep going, but this should be kind of a clue that, oh, something weird's happening. Both these sides are exactly the same, so something interesting is going to happen. I'm going to go ahead and keep solving. I'm going to try and get those variables on the left. So I'm going to subtract x on both sides. And just like the previous problem, these are going to cancel, and the left side's also going to cancel. 1 minus 1 is 0, so all the variables cancel out, and now I'm left with negative 1 equals negative 1. Okay, unlike the top where it was a not true, where negative 20 and negative 20 and negative 27 were not equivalent, now we're in a situation, well, all my variables are gone, but my two numbers equal each other. So this is a true equation, and this would yield us infinite solutions. We can also say to this problem, and you're going to see this pop up, you can also say all real numbers. In fact, that's probably a better way to write your answers, all real numbers. Any real number you could plug in for x will work here. Okay. So 2 things to think about in this learning target. Can you solve equations using the distributive property? And if your equation shows up with infinite solutions, no solutions, or 1 solution, can you recognize that and make note of that? So those are your 2 big goals for this learning target. There is a pretty significant amount of practice in this learning target, so take your time, show your work, and ask questions when you need help. Good luck, guys.